Hello everybody, this is the fourth video of the video series about feature engineering techniques. In the previous videos I explained the pipeline, the feature improvement, feature construction and the feature selection. Now I will explain the feature extraction, another important feature engineering technique. And like in the other videos, I will show a few examples. First of all, what is feature extraction? Simply by using raw data like text, image or some files, we are creating new features. So we are extracting the features from the raw data. So what is the difference between the other techniques? In the first one, feature improvement, we already have some features and we just improve their contribution. In the second one, feature construction, we used existing features, not the raw data, and we created new features by using our original features, not raw data. In the feature selection, we select the optimal subset from our original feature set. Again, we are not using raw data. But in the feature extraction, we have a raw data, some text and image. They cannot be used to train the machine learning model. We need a numerical representation, numerical values. So thanks to feature extraction, we will be able to train our models because the output of the feature extraction will be numerical representation of our raw data. In the feature extraction, data type is important. It determines the technique. If you have text data, you can apply some vectorization techniques like CountVectorizer, TF-IDF, or if you have image data, you can apply histogram of oriented gradients or other techniques. Also, principal component analysis, PCA, and singular value decomposition, these are also categorized under the feature extraction techniques. In scikit-learn, we have a feature extraction section, and I will show a few examples from there. Let's start with our first example. Imagine we have a dictionary as a raw data, and in scikit-learn feature extraction, we have dictionary vectorizer. So it is somehow text data. So maybe from a survey, you collected some data, and then you have a dictionary. As you see here, we have age, numerical feature, and also country. This is categorical feature. So simply, we are instantiating vectorizer, and with our raw data, with this dictionary, we can fit and transform this vectorizer, and after converting to array, as you see here, we have a numerical representation of our raw data. So 32, 28, 52, these are the age. And as you see here, other part is a one-hot encoded form of the country. So we have three categorical value in this small data. Therefore, we have three dimensions. And if you look at the feature names, it will be more clear. You can see we have age, first dimension, and the country India, Turkey, and the USA. These are other features. So we can just simply define a data frame, pandas data frame, with our data. This part will be the data, and the column names will be the feature names. So I'm using get feature names out, the same method here. So as you see, age, and these are the other features, and this is a numerical representation. Of course, this is small data, but when you have more data, you can use different machine learning regressor classifier algorithms with this data. The second example, again, you can have text data. So corpus basically has some documents. So each sentence is a document in this case, and each document has some tokens. So we know that we cannot use this text data, this raw data, to train our machine learning model. We need to convert it to a numerical representation, to vectors, for example. So let's import this one, define the corpus, and here I define a simple function as a preprocessing function. We will remove some punctuations. You can define advanced preprocessing functions. I added to show an example, and here you can see we are using string package for the punctuation, and we are just replacing punctuations with empty. So define this function, and in the CountVectorizer, we imported CountVectorizer from scikit-learn feature extraction text, and while instantiating the vectorizer object, we can use also the preprocessor parameter of CountVectorizer. This is very helpful. You don't have to use it. If you have some preprocessing requirements like remove punctuations, maybe remove stop words or normalize the text data, you can define a function and then you can give this function as a parameter in the processor. So I defined a remove function and give this here. And after instantiating, I can simply fit and transform this vectorizer with my corpus, with my raw data. And then when I call this toArray method, you can see each document, each sentence, now instead of text, words, I have numerical values, numerical representations. Of course, the CountVectorizer, TF-IDF vectorizer, these are a bit primitive today. We have embeddings, but this is just simple example of feature extraction. And this is the data frame display. Here, each token is a null feature, and each sentence in our corpus is represented by a vector. So this is one vector, second, 3, 4. Now I want to show another example. Let's assume that your raw data is an HTML website content. So basically you can use different tools. You can use Python request library or different tools to obtain the content of HTML, and you will have something like that. This is just a simple HTML content. According to your problem, of course, you can have different feature definitions. Let's assume that our features are number of pop-up and number of hidden state. So basically we are trying to understand if there is any pop-up as a button. If yes, what is the number of that pop-up? And second feature is if there is a hidden div. Of course, you can customize this part. So this define the HTML content variable here. And I will use this BeautifulSoup model. I already installed this package, therefore I will not install again, but you should install this BeautifulSoup. Then you can import BeautifulSoup from bs4. And I defined two simple functions for our two features. Input will be HTML content, and then with the BeautifulSoup, we will create a soap object. The first parameter will be our input, and the second one will be HTML parser. And after creating this object, we have some very useful methods like find or find all. Then simply you can say that find all buttons, and when you find them, just check these attributes. If you see them, then we have pop-ups. So return the number of pop-ups, length of the pop-ups. It will generate a list, an array. And second one, the same, just I changed the target elements here. You can see div and style. So based on the content, you can define different features. And let's run this. So I just run this function and pop-up content and hidden state count and simply define a data dictionary. So, and you can see I added also synthetic data just to increase the number of rows samples. Okay, but basically instead of this raw HTML content, we can define some functions, we can extract the features, and then we can have these numerical representations, and we can train our machine learning model. And the last one is the principal component analysis. This is a bit different from the previous ones because in the previous one we have raw data like text, image, but here you can have some features, and by applying principal component analysis, instead of using your original features, you can create new components, and those components can cover and can explain the variance of your feature set. So you can use them to train the machine learning model, and by doing this you can reduce your cost a lot, especially when you have a lot of dimensions like 1500. The computational cost will be expensive. But instead of using all, you can apply PCA, and then you can have only 3, 5, 10 components. Of course, you should evaluate your model. You should check if those components are enough or not, then you can continue with them. So from scikit-learn decomposition, we need to import PCA, principal component analysis, and I will use this fetch code type dataset. So this is a cover type of forest in a specific zone of United States. So basically we have 7 different types and we have a lot of features. I will not go to details of the dataset because the focus is just the PCA. So you need to load the data after importing. Then you can see the number of features. We have 54 features, and we can create a data frame by using this data and also feature names attributes of our original data. Then you can see we have some features, 54 different features, and we have nearly 581,000 samples rows. So this is a huge data for the machine learning models. Okay, first of all, we need to create our X and Y. So data will be X and the target will be Y. And you need to split your data into train and test. In the previous examples, I didn't follow these steps because I just wanted to show some feature extraction techniques. But in real-life scenarios, while applying any of these techniques, you should be very careful about data leakage. For example, in this case, in the PCA, we will apply PCA, but any fitting part should not be performed with the test data. So what does it mean? Let's look at these examples. So first of all, split your data into train and test with our train test split. By the way, this is the fourth video, so I already imported some packages in the previous videos, therefore I'm not importing them again, okay, like train test split. So after having this train and test data, in the PCA, scaling is highly recommended, especially when your data is not in the same scale, on similar scale. You can see we have very different scales here. Therefore, we should apply scaling, and I will use standard scaler. So instantiate a scaler object. Then, while fitting the scaler, don't use test data. Otherwise, it will cause a data leakage. So I use trained data to fit and transform, and only test for the transform. So I have xtrain scaled and xtest scaled. Then I can create my PCA object. So here I'm using this PCA, and you can specify number of components. You don't have to do that, but I want to have 10 principal components. So I specified these. Of course, this is just an example. Ideally, you need to check different number of components to see their impact, their contribution. Iteratively, you can try different number of components and you can see their impact. Okay, we have PCA object. Again, the same. For the fitting part, we are using only the train data. So xtrain scaled, we scaled the data. Now we can give to the PCA, and xtest scaled only for the transforming part. So we have now xtrain and xtest. So we can use them to train our machine learning model. Here you can use different machine learning models. I just wanted to use one of them, stochastic gradient descent classifier. So import it. So default model, and then fit with train PCA data and my train. So it depends on your computational power, but after 5 or 6 seconds, the training will be completed. And then here I can make the predictions, and I imported accuracy score from scikit-learn metrics, so you can also import other metrics like recall, precision, etc. But I just wanted to show one thing to you. Here, with this accuracy, I'm using actual data and predicted data. Accuracy score is nearly 63. Not very good, but without PCA, if we use all of the features instead of 10 principal components, let's assume that we are using all features. So I'm again instantiating an stochastic gradient descent classifier, and instead of xtrain PCA, I'm using xtrain scaled, and create predicted values and the accuracy. Here you can see our accuracy is 70 nearly. So the difference is not too big, right? Instead of 54 features, 54 dimensions, we used only 10 principal components for 10 dimensions. So we reduced the cost a lot, especially when you consider the whole amount of data, because we have more than 500,000 data. And of course, with different optimization techniques, with different models, you can also increase this accuracy score. Okay, that's all. We covered different feature extraction examples, and I hope you get the difference between the feature extraction and other feature engineering techniques. The next video will be about feature learning, and I will also conclude all of these feature engineering techniques video series in the next video. So thank you for the watching. See you in the next video.